7, it wants you to rewrite this in y equals a over x minus h plus k form, and then it wants you to graph it. So if you remember, we have the reciprocal function, the parent function is y equals 1 over x, and it looks like this, if this is our y and x axis. The h is going to be a horizontal shift, and the k will lift it up. So it would help us, we could just kind of draw a little sketch of this without having to plot any points if we just had it in this nice graphing form. So the book shows us a couple ways to do it. My favorite way to do it is just use some long division, but I'm also going to show you another way because I noticed that your answer key did it the other way. This way, if you know how to do long division, will work every time. Well, actually, well, yeah, it should work. So x goes into 2x 2 times, and x times 2 is 2x. And then you have to go -1 times 2, and that's -2. So that's the division part, and then you subtract. But when you subtract, it's kind of like you're distributing the negative, so these will cancel out. And this will be like -7 minus -2, so it's -7 plus 2, so this will give you -5. Now, this can't go into -5 evenly anymore, so it's a remainder. And so you write it as 2 is the whole number, and then plus the remainder. So that's -5 over x minus 1. So this is kind of already written in the form that we want, but I want to show you another way because I noticed the book did it. You can also do it this way. This way it confuses me a little bit, but you can kind of like pull apart all the stuff on the numerator. Like this thing, 2x is like x plus x. And then the -7, that's like -1 plus -1 plus -1 plus, you know, like, so there's 7 of them there. But I don't really want to pull the -7 all the way apart, so maybe I'll just write it as -1 plus -1 plus -5. I mean, I could write all those -1s out there. I could list all the negative, or all the 7 -1s, but then I'm going to end up probably combining them again anyway. And that's all over x minus 1. And so I noticed that your answer key kind of like does some little rearranging. So we'll just like this x and this -1, I'm just going to kind of like rearrange them. And then maybe this x and this. Kind of just put them together somehow. Well, I can pull these apart. I can say, well, this is x minus 1 over x minus 1 plus, like I'm kind of like paired these two up. And then these two, well, that's x minus 1 over x minus 1. So I paired those up. And then I've got the 5 over x minus 1. Well, this is 1 and this is 1, so it's like 1 plus 1, and we got this leftover part. So this is really 2. And so this is neat because maybe it gives you some kind of insight to fraction math or something like that. And this will help you because you are going to have to do the partial fraction decompositions at some point if you go into calculus and you're trying to take some derivatives or integrate certain things. You'll want to know how to do this kind of thing. But for now, if you didn't really get this part, you can just do your long division. So now we have y equals a, well, we'll have the a be like -5 over x minus h, x minus 1 plus k. So I just kind of rewrote it in the graphing form, and then from there I can just draw a really, really quick and easy graph. I'm not going to concern myself a lot with plotting points. So I'm just going to let this be y and this is x. So I know it's going to be a vertical shift by 2, and I like to draw a little dotted line, and horizontal shift to the right by 1. Draw my little my vertical line, dotted line. And then normally the parent function graph, normally I would just like real quick sketch a little my graph here and here, but this one has a negative up here, and it's also got the 5, which gives it a little vertical stretch. But because it has this negative, it's going to actually reflect over the, well, I'm not going to say the x-axis, but it's going to have this reflection. It's actually going to go this way, like this, and like this. And I don't know, maybe maybe I was a little careless, and I don't know exactly where it's crossing these axes. I can go ahead and plot some points and figure it out if I want to. This one I actually did just because I was messing around with it, and I put the 0 in there. Well, you can do it in your mind. Put the 0 in there, you'll get 5 plus 2, that's 7. So we know that this up here is 7. So maybe I'm not drawn to perfect scale here, but that kind of also ensures or makes you more confident that the graph goes this way and this way. So I think that's all really that is required for this problem.